Here's how to wire an ultrasonic sensor with an Arduino Uno. The ultrasonic sensor only has 4 pins that we need to wire, and 2 of them are just ground and power, so it's actually a pretty simple sensor to use. You can start by plugging the sensor directly into your breadboard. Since I'm just demonstrating how to use the sensor, I can directly wire my Arduino 5V and ground pins to the sensor's ground and power pins. If you're using the sensor with any other components, I would recommend still putting them into the rails, but since I'm just doing a demonstration, I can directly wire them. So next are the trig pin and the echo pin, but before we know how to wire these, we need to understand how the ultrasonic sensor works. An ultrasonic sensor measures the distance between itself and an object by measuring how long it takes for high-pitched frequency waves to bounce off the object and return to the sensor. We can actually see real-world examples of this through when bats use things like echolocation to find food or navigate through the dark, or in more man-made objects like cars when they have a backup camera. They use one of these to figure out how far an object is from it and to tell you whether or not you should start braking. The trig and echo pin need to go to digital pins, so I'm going to plug mine into 8 and 7, but it doesn't matter which one you put them into. Now for the code, we can start off simple by declaring what we plugged our trig and echo pins into. And I'm going to declare mine as constant ints instead of just ints, since these numbers are never going to change. In the void setup, we can set up the serial monitor, since we actually want to print out the distance that the ultrasonic sensor is measuring in centimeters. And the final thing we need to do in the void setup is declare the pin modes of our trig and echo pins. If you think about it, the trig pin, or the trigger pin, is the one that's actually sending the signal out, so it's going to be declared as an output, while the echo pin is the one that takes in the signal when it returns to the sensor and calculates how far something is, so this one is declared as an input. Now that we've declared everything in the setup, we can move on to the void loop. And similar to the void setup, the code is actually pretty simple for this as well. We're going to start by using digital write with our trig pin, just like we would with an LED, to turn the trig pin off, or set it to low. This way, whenever our void loop repeats, we'll have a clean slate to start with and we won't be sending out any signals. Next, we're going to use a built-in function called delay microseconds. This function works the same way a regular delay would, but with microseconds instead of milliseconds. A microsecond is 1/1000th of a millisecond, so we're using a much shorter delay with this sensor compared to other sensors. This will help us get more accurate readings when determining the distance of an object as it moves towards or away from the sensor. We'll delay by 2 microseconds before setting our trig sensor to high, meaning it will start sending a signal out. We're going to keep sending a signal out for 10 microseconds before turning it off again, so we can actually read what our signal is hitting. We're then going to declare a new variable in the void loop as an unsigned long, and call it duration. This is where we'll save how long it takes our signal to return to the sensor. We can measure this by using another built-in function called pulse in to read our signal, and set the echo pin to high. Then we'll need to declare a distance variable to know the distance of our object based on the time or duration that it took to receive the signal. And it's calculated using this formula that you don't need to memorize, but it is important that you put the parentheses around the first part before dividing by 2, because if we don't do this, then our values will be off. The final thing we need to do is simply use print and printline statements to print out our distance measured by the sensor in centimeters. And once we do that, we can go ahead and hit upload, and as you can see, when I move my hand toward or away from the ultrasonic sensor, it accurately updates the distance that my hand is from the sensor in centimeters. Now that we understand how to wire the sensor on its own, we can try to pair it with other components, such as LEDs. Try to make it so that when you move your hand toward or away from the sensor, certain LEDs turn on or off. Or if you want a different challenge, try to pair the sensor with a passive buzzer, and have the passive buzzer make certain notes of certain pitches when you move your hand toward or away from the sensor. That's all for this video. Leave any questions you have in the comments and I'll try and answer them as soon as I can. Until next time.